What's up? Alright, so today we're going to talk about square roots. Now, this is probably something you've heard of before. You probably know that a square root is this symbol there. But what is it? What is a square root? Well, to answer that question, what we need to understand is, what is a square? Well, a square is an exponent. Exponent is that little bitty number at the top of another number, such as this. If I see 4 and I have that 2 there, that 2 right there is a square. Now, it is called that for this reason. It is actually an exponent of 2. And what we all know is exponents are telling us that's how many of this base number you want to write down and multiply together. So 4 to the second power means put down 2 4s. That's what the 2 stands for, 2 of them. Multiply them together. So you know that that equals 16. So we don't refer to that as 4 to the second power. We refer to that as 4 squared. So 4 squared is indeed 16. Now, in math, anytime you learned any operation, think back to when you were a little bitty kid in school and they taught you how to add. What was the next thing they taught you? How to subtract, right? Why did they do that? Well, in math, if we know a way to do something, we need to know a way to undo that thing. These are what is known as inverse operations. So when we're talking about a square root is essentially the inverse of squaring. Now that just means it undoes it in math speak. So this is the inverse of squaring. So when I see the square root of a number, and we'll put that 16 underneath there, what I'm really doing, and this is where a lot of teachers don't demonstrate this, what I'm really doing is I'm saying to myself, okay, what number do I square to get 16? So in other words, I can write the square root of 16 as the square root of 4 squared. And since they are inverse operations, since they undo each other, that root and that square undo each other, so the square root of 16 does indeed equal 4. So hopefully right now you're seeing the reasons as to why I've asked you to memorize your perfect squares. It's very hard to do a square root if you don't know what your perfect squares are. If we know 4 squared is 16, I can take the square root of 16. If I know that 7 squared is 49, I can do the square root of 49. So that's why it's important to memorize those things. Now, with that being said, it should be very, very easy to square root those nice perfect squares. For instance, if I say the square root of 100, well, hopefully we all know that 10 squared is 100. So the square root of 100 can be written as the square root of 10 squared. Since square roots and squares are inverse operations, they cancel each other out, and the square root of 100 is 10. And that can continue forever for every perfect square. So if we do the square root of, let's take 64. I know that the square root of 64 is the square root of 8 squared. And since roots and squares are inverse operations, that means the square root of 64 is indeed 8. Now I know this adds a little bit of a step that you probably have not done before, but I would like you to do that for now, just to make sure we understand the process of what a root is. So at this point, what I would like you to do is I would like you to pause the video, and very quickly I would like you to do these two. Let's do the square root of 121, and let's do the square root of let's just go with 36. Do those real quick, show your steps, come on back. Welcome back. Hopefully you discovered that the square root of 121 is 11 through your steps, and the square root of 36 is 6. If you do not have those, you probably need to work on your perfect squares, then you can come back and reattempt those. Now, there's one problem with square roots. If you start thinking about those perfect squares, and I'll just put down a few. We have 3 squared, that equals 9. We have 4 squared, that equals 16. And we have 5 squared, that equals 25. So what's the problem, you might ask? Well, it's pretty simple to understand. If I put up the square root of 9, you can look at that and say, oh, okay, well, I know that 3 squared equaled 9, so the square root of 9 is 3. If I put up the square root of 16, it equals 4. And if I put up the square root of 25, it equals 5. Yeah, common sense, right? However, I want you to think about all of the numbers in between there. What about the square root of 10? What about the square root of 21? What about the square root of 26? What about all of those? There's a lot of numbers between 9 and 16 and 16 and 25 that I could put underneath the square root symbol. The problem is, if 3 squared is 9 and 4 squared is 16, what do I square to get 10? What about 11, 12, 13, 14, 15, all those numbers in between? What about 12.5? So there are a lot of numbers that we put in there that we cannot find a nice, pretty number for. Now, if you think back to our sets of numbers, what that turns into is when I have the square root of a number like that, let's put that 10 there, what I want to be able to do is this. I want to be able to look at that and I want to say, okay, the square root of 10, since I know that the square root of 9 is 3, and I know that the square root of 16 is 4, what do I know about the square root of 10? I know that the square root of 10 lies between 3 and 4. I know that it is 3 point something. Since it lies between 3 and 4, it has to be 3 point something. So here's what I'd like you to be able to do. We're going to do some examples of this. I would like you to look at the square root of 10. Since it does not have a nice, pretty root to it, we're going to look at that and say, hey, you know what? That guy is irrational. I want you to think back to your sets of numbers that you've learned. That is irrational, and that it lies between 3 and 4. So it's 3 point something. This is all we're going to do for this moment. Okay? So I'm going to put 2 up here. I'm going to show you the process that I want you to follow, and then I'm going to let you try some on your own. So let's put up 2 examples. Let's do the square root of, let's go to 75. And let's do the square root of 169. Okay, so here's what I'm going to do when I approach the square root. I'm going to first look at that. I'm going to say the square root of 75, and I'm going to ask myself, is there a number that I can square and get 75? Can I think of that nice, pretty number? And as I go through my list of perfect squares in my head that hopefully we have memorized, I would go, no, I can't think of one. So that leads us to the first part. We want to be able to say, hey, this guy is irrational. So part B is, well, what perfect squares does it lie between? In other words, what numbers, nice, pretty integers, is the square root of 75 between? Well, if I take a look at the square root of 75, I know that that would lie between the square root of 64 and the square root of 81. That tells me that it lies between, since the square root of 64 is 8 and the square root of 81 is 9, that means it lies between 8 and 9. Or I could say it is 8 point something. That's what I want to be able to do with that, just for now. We'll learn a better way to get a more accurate estimate for this, but for right now, that is all we're going to do. When it comes to number 2 example up here, I look at the square root of 169, I start going through my perfect squares, and I say, is there a number that I can square and get 169? The answer to that is, yes, there is. That is a nice, rational root. He is indeed rational. So, the square root of 69 is the square root of 13 squared, which cancels out, and is just 13. So that's what we're looking at. We're looking at roots. We're going to make that first decision. Is it irrational or rational? If it's rational, give me the answer. If it's irrational, find out what 2 nice, pretty square roots it lies between, what integers those go with, and tell me what it lies between. It's 8 and 9 or 8 point something. Got it? Okay. let's put two examples up here and let's have you do them. And as you can probably predict, one's going to be rational, one isn't. So here we go. Your examples that I would like you to try. Let's do the square root of, let's go with 196. And let's go with, we'll do two 3-digit numbers. Let's do the square root of 110. Go ahead, pause the video, give it a whirl. Welcome back. So we take a look at the square root of 196, and we know as we go through our perfect squares, we go, hey, I do have a number I can square and get 196. That means it's rational. The square root of 196 does equal the square root of 14 squared because 14 squared is 196. And of course, the square root of 14 squared, roots undo squares, that equals 14. I get to the square root of 110, go through my perfect square list. Is there a nice, pretty number that I can square to get 110? There isn't. I know, however, that, well, first off, that tells me it is irrational. And I do know that the square root of 110 would lie between the square root of 100 and the square root of 121. That tells me, since the square root of 100 is 10 and the square root of 121 is 11, that the square root of 110 lies between 10 and 11, or I can say it's 10 point something. So hopefully that makes sense. What I would like you to do next is you're going to practice this. You will see some of that in the practice it section, and then we will move on. Hope you enjoyed. See ya.